Hello, children. Welcome back. Now I'm doing 10th class real numbers, the continuation of the topic which I'm doing in the previous video. So before going to that, let us talk about the proverb. What is the proverb, children? Still water runs deep. Still water which is not in movement, that runs deep. If you see this, best example is a sea, children. When you go to the sea, on the shore of the sea, you can see plenty of waves coming and going. Usually, all of you, if you might have gone there, you like to play there. But if it happens to you to go deep into the sea by a ship, suppose you are voyaging to some other place, in that, if you really personally feel that experience, that's really awesome, children. When you go deep into the sea, you can look at the sea just like a road. It appears as a road because when the means the this you can see when the weather is very calm, quiet, and it there is no sign of any storm or any rain. At that time, the sea, the water will be just like dark blue or sometimes even black. When the depth is more, even it appears as black. You might have studied about the Black Sea in social studies. So it looks like that, where you feel like to, oh, I think it is a road, I can walk upon it. It is just like that. Why it happens so, children? The sea looks very calm because it is very deep. And you know, in the depth of the sea, so many treasures you can find in it. Okay, so this can be compared with our status of mind. If our mind is wavering, it will not be fixed to one point and you cannot concentrate. You cannot get the treasure of your education. Instead of that, if you point out a particular task and if you go in deep of that knowledge, means very deeply immerse in preparing for that particular topic, then definitely knowledge is yours, success is yours. Let us come back to the topic, that is the 10th class syllabus, Telangana state syllabus I am doing. I have done earlier theorem 1.4 I have done. Now I am going to do the next part. The next part is about non-terminating recurring decimals. Non-terminating means what, children? Non-terminating means you will never get zero while dividing. Recurring means again and again the quotient will be appearing. So let us see. For example, let me take 1 by 7. Now I have to divide this 7. What should I do, children? I should keep a point 0. 7 ones are 7. 3 0. 7 fours are 28. 2 0. 7 twos are 14. Again 6 0. 7 8 are 56. 4 0. 7 fives are 35. 5 0. 7 sevens are 49. Again you got 1, children. See, this one I am getting it repeated. So if I take 0 here, again what I will do, 7 ones are 7. It goes on like this. So from where I am getting repeated this? From 1. That means how can I write 1 by 7 as 0.142857? Again 142857. It goes on like this. That means in your lower classes you have put this bar, children. 142857 bar. That means what? These terms, these values are repeating again and again and again. Are they ending at any time? Do you get 0? No. So non-terminating, and this part is occurring again and again. So reoccurring decimals, non-terminating, reoccurring decimals. So if you see the denominator, is it in the form of 2 to the power of m or 5 to the power of n? No, it will not be in the form of 2 to the power of n and 5 to the power of m. So you copy this, children. Next, the next part of it. You have do this sum section. Do this in the same page. 12. What are these? Do this says write the following rational numbers in the form of decimals and find out the block of repeating digits in the quotient. What block is repeating? Earlier I have done one problem. No, I keeping a line bar upon it. So what is that block which is repeating? You need to find out. You have got 4 bits, children. One by one we will do. The first one is 1 by 3. So what you will do? You divide. 3 threes are 9. Again 1, 0, 3 threes are 9. So it goes on like this. So this can be written as 0.33, so on. So this means 0.3 bar. So block of, what is the block of repeating block? I'll write. Repeating block is 3. 3 is repeating here. Now let us see the second bit. The second bit is 2 by 7. So what you will do? You have to divide 7. 2 by 7. So 0.0. 7 2s are 14. 6 and then 0. 7 8 are 56. 4 0. 7 5s are 35. 5 0. 7 7s are 49. 1 0. 7 ones are 7. 3 0. 7 fours are 28. 2. So here 2, this 2 is repeating here. That means 7 fours are 28. Afterwards again you will be getting 2 8 like this. So what you will write is 0.285714, 285714. It goes on like that. This means you can write it as 0.285714 bar. So what is the repeating decimal? Repeating block? Repeating block is 285714. So you copy this, children. Remaining I will do in the next part. Now we will go to the next one. Third bit. Third bit here is 5 by 11. So 5.0, 5, 11 fours are 44, 6 0, 11 fives are 55, 5 0. So again you will be getting, see this is repeating, 11 fours are 44. It continues like this. So what you are going to get here? 6. So 11 5 by 11 is nothing but 0.4545, so on. This you can write it as 0.45 bar. So what is the repeating block? The repeating block is is 45. Now let us go to the fourth bit. Fourth bit given here is 10 by 13. So 13, 10. Keep a point here. So how much you will be getting, children? 13 sevens are 91. How much you are getting here? 9 and 0. If you keep 0, how much you can get? 13 6 are, you can write 13 6 are 3. How much you will be getting, children? 78. Okay. 13 7 are 91 is greater than this. So 13 6 are you'll take. So how much you are getting? You'll be getting 2 here and here 1. 120, no? 8 minus 7 is 120. 120 means, keep a 0 here, 120. 120 means you can go for 13 9 jar. 13 9 jar 117. So how much you are getting here? You are getting 3 here and 0. Okay, then 13 2s are 26. 4 0. So I'll do it here, children. You may not see it. This 40, when I go for 13, 13 3s are 39, 1. So here you see this 1 is repeating. So what I can, 3 I have to write here. 13 3s are 40, no? So this 3 I am writing it here. So again what I am getting? 1. 1 means 0. Again 7, 6, so on I will be getting. That means 7, 6, 2, 3, 7. Okay. 7, 6, 2, 3 is the repeating one. 7, 6, 2, 3. So what you are getting? 0.7692 7, 6, 9, 2, 3, so on. So what you are getting, children? 0.7692 bar. So what is the repeating block? Repeating block is equal to 76923. Okay, children, this is the answer. I hope you have understood. Basing on this, we are going to talk about the next theorem. Copy it. Now, let us see the next theorem. The theorem that is given to you is theorem 1.5. So let me just talk about the problems that we have taken in do this, children. One is 1 by 3. I have already done this. Second is 2 by 7. And third bit is 5 by 11. And fourth bit is 10 by 13. In all these cases, when you are observing the denominators are neither having 2 or 2 powers, nor you are having 5 or 5 powers. So what you are getting, children, when we have done the problem? We got the answer as a decimal part which is non-terminating and recurring. In the earlier cases, or when we have done some problems where the denominator is occurring either by 2 or 2 power something or 5 power something or 2 and 5 powers of some values, you have got terminating there. You have got 0 there. In the previous video, if you observe, you will get it. So in that, if you are having the denominators in the form of 2 or 2, 5 or 2 and 5 to the power of some numbers, definitely you are going to get 0. That means definitely they are terminating decimals. You need not divide the lengthy division, you need not do and find out. Just by looking at it, just by seeing the denominator, you can understand whether it is a terminating or non-terminating. So in this case, what are we getting? We are neither getting 2 nor getting 5. So non-terminating and repeating decimals will have always a denominator in will be in some other form, but not in the form of 2 to the power of n and 5 to the power of m. So the same thing is given in theorem 1.5. So the theorem goes like this. You have to write this theorem in your classwork, children. So let me read for it. Let x be a rational number such that the prime factorization of q is not in the form of, see children, not in the form of 2 to the power of n and 5 to the power of m, where n and m are non-negative integers, then x has a decimal expansion which is non-terminating and repeating. Repeating in the sense recurring. So reoccurring or recurring. So whenever you see that the denominator is not in the form of 2 to the power of m and 5 to the power of n, you can immediately say that it is non-terminating recurring decimal. Okay. Now let us go to example 5. That example 5 you have got in the page. You have got it in the page 13, children. Example 5 in page 13. So let us see that. Example 5 in page 13. So page number also I should change. So we are going to do now page 13, example 5. What does this example 5 says? Using the above theorem. What is the theorem? It goes on like this. What is the theorem? That is theorem by 1.5, which I have explained you just now. Using the above theorems without actual division, state whether the decimal form of the following rational numbers are terminating or non-terminating, repeating. So to answer this question, see children, now chapter wise we are going. Just now we have learned that it is easy for you to answer, but when you are getting the same question in the exam, you should have a thorough knowledge about this. Terminating decimals will have denominator as 2 or 5, 2 to the power of some number, 5 to the power of some number. But non-terminator will not have 2 or 5 in the denominator. So let us see. The first problem given to you is 16 by 125. So let us write 16, 125 prime factorizations. 5 2s are 5 5s are 5 3 5 5s are, that means how much children? 5 cube. So denominator has 5. Therefore it is terminating decimal. Understood children? It is a terminating decimal because of this reason. Now let us see the second bit. 25 by 32. 25. Now go for 32. 2 ones are 2 6 are 2 8s are 2 4s are 2 2s are. How much you are getting? 2 to the power of 5. So here denominator has 2. Therefore it is terminating decimal. See children, without doing such a long divisions, you can directly observing the denominators, you can say whether it is terminating or not. Now what is the third bit? Third bit is 100 by 81. So when you take 81, 3 ones are 3 sevens are. Okay, so what you are getting? It is denominator is in the, oh, this is 100 by 81. 3 twos are 6, 3 sevens are 3 nines are 3 threes are. So how much you are getting, children? 100 by 3 to the power of 4. Denominator has not got, or you write it in a denominator is not denominator is not in the form of 2 to the power of n and 5 to the power of m. We are not getting anything. So what you will say then? Therefore, it is non-terminating, repeating decimal. Non-terminating, repeating decimal. Now we go to the fourth bit. Fourth bit is 41 by 75. 41 by 75 means take 75. 5 ones are 5 fives are 5 threes are. So we are getting 41 by 5 square into 3. In this case, even though there is 5 in the denominator, you have another number 3. We are not supposed to have any other number except 5 and 2. So because we have got 3, we will say that denominator is not in the form of 2 to the power of n and 5 to the power of m. Hence, therefore, I will say that it is non-terminating, repeating decimal. It is non-terminating, repeating decimal. So I hope you have understood this, children. Just copy it. Now we will go to the next example in the same page. This is example 6. Example 6. Write the decimals. You have got the problem like this. Write the decimal form. You have to write the decimal form of the following rational numbers without actual division. Earlier, if you want to find out the decimal, you have to go for the long division and do. But there is a method in which, without actual division, you can write the decimal form. What is that? Let us see. It's a very important sum, children. So, the first bit is 35 by 50. 35. Here, in this case, what you have to do is, numerator, you can take factors, that is 7 5s are, and denominator 50 means how you will write prime factorizations. 5 10s are, 5 2s are. So you will be getting 5 into 5 into 2. This 5 and this 5 will get cancelled. So you are getting 7 by 10. 7 by 10 means you can write it as 0.7. You have converted it into decimal without dividing, children. I hope you have understood. If I do the second bit, it will be more clear to you. That is 21 by 25. So, take 21 as it is. 25 you will be writing it as 5 square. 5 square is 25. Now, I should get in the denominator any form, 10, 100, 1000 like that, means 1 and some zeros. I have to manipulate my problem in such a way that I should get only 1 and 0. That means if I have 5 square, if I take 2 square here, 5 square into 2 square, 5 2s are 10, 10 square is 100. So I can, if I take 2 square here, see children, what is happening? I have done a harm to the given problem. How? By taking some other extra number. Am I eligible for it? Can we do like that? We can only manipulate the problem, but we cannot add or subtract or multiply or anything with some number by ourselves. So what I have to do? I need this 2 square here in the denominator. But I should not do. That means what? I should cancel this 2 square also. How can I do it? Just by writing another 2 square in the numerator. So, I did not do any harm to the problem, children. Now, if I cancel this, I'll get 25 by 21 by 25. So, only by taking this, what am I getting? I could get that denominator in the form of 1 and 0. So, I will write it as 25 into 4 by 5 into 2 whole square. That means for 21 fours are 84 by 10 square. How much, children? This is nothing but 84 by 100. 84 by 100 can be written as 0.84. 2 zeros means 2 decimals. You know that. So 0.84 is the answer for this problem. Okay, now go to the third bit. What is the third bit given here? 7 by 8. 7 by 8, you know 2 cube. 2 cube is 8. So here you have got, just like how you got 5, here you have got 2. We know that 2 5s are not 10. So what I should do? You have 2, so I should take 5. How many 5s I should take? Same power as that of the 2, 5 cube. As I am taking 5 cube, I should take 5 cube in the numerator also. So how much I will get in the numerator? 7 into 125 by 2 into 5 whole cube. That means 7 5s are 35, 7 2s are 14, 3 17, 7 1s are 7, 1 8. 875 by 10 cube you will be getting. This means 875 by after 1, 2, 3 zeros. So what, children? You will be rating 0.875 is the answer for this problem. So see children, in all these cases, what we have done, if you have 5, you have taken 2. How many 2s you have to take? The same power as the 5. Here you have 2, you have taken 5. But whatever you are taking in the denominator, you should take it in the numerator and you should continue your problem. I hope you have followed, children. So let me conclude this. Exercise 1.3 is there. That exercise 1.3 I will be doing in the next class.